All right, so today what we're going to do is we're going to look at 3 different measures that are really important, incredibly important in statistics. And these are often called measures of center because they tell you what's happening in the middle of the data, right? Because remember when we had outliers? You can have outliers on either end of the data. So let's say that we were measuring how many days you were absent last year, and one person wasn't absent any. But then there was a bunch of people who were absent like 2 or 3 or 4 days, and then there was one person who was absent 20 days. Okay? Well, that person that was absent none, and that person that was absent 20 is really not telling you. You can't look at it and say, oh, the average Queen Margaret student missed 20 days, when most of it was just 2, 3, or 4 days, right? And you can't look at it and say the average Queen Margaret student missed no days, because that's not true either. The answer lies in the middle, where the bulk of the information is. And so that's why we look at measures of center to help us describe data. Because if I wanted to tell you, all right, what the average number of absences was at Queen Margaret, I wouldn't say, oh, well, Jill missed 2, Sarah missed 3, right? You wouldn't just name off all those numbers. You need a number that's representative of what's happening. And that's what we're doing here with measures of center. And you've heard these and done these a million times before. You're just going to do them again. All right? So let's talk about them. The first one is something called the mean. And usually, that's the one, if you say the word average, we usually think of the mean. Now, really, all of them are averages. Okay? But if you see average, you generally think mean for that one. Now to remember to find the mean, it's very easy. The mean is simply the sum of the data divided by the number of data. Right? So, the sum, and what does sum always mean, guys? Add. Anytime you see that word sum, you always mean to add. Okay? So we have the sum of the data divided by the number of data. So for example, say that we have the number of dogs in a particular group of people, and they said 1, 2, 3, 7, 0, 9, 4. Now, 0 is an actual number that can be answered in this question, is it not? Yes. So that makes it one of the data points. So be careful, don't leave things out. So how many people did we have answer in our survey? 7, right? So 7 is the number we're dividing by, right? Now, the top number is the sum of the data, which means we just need to add them all together. And it doesn't matter which order you add them together. We can see that 3 and 7 make a 10 there. This 9 and this 1 make another 10. And this 2 and this 4 make a 6. And 10 and 10 are 20 plus... That makes 26. Yeah. Right? Remember, as long as you're doing the same operation, you can group them any way you want to. And will 26 divide evenly by 7? No. Let's add one more. We'll add another 2. Okay? Which turns our number into 28. So 28 will divide by 7. I'm just manipulating the numbers so it would divide. Okay, 28 divided by 7 gives me 4. So we can conclude that from this group, the mean number of dogs is 4. Right, because 28 divided by 7 is 4. Now, all I did was add the top numbers. Add all the numbers and put it over 4. And over there how many there are. I got 4 because 28 divided by 7 is 4. The second one we're going to look at is something called the median. Okay, so there's a median. Now, if you were drivers, you would know that the median is that little strip in the middle of the road, right? You've heard of that probably anyway. The median simply means the number in the middle but it's the number in the middle of an ordered set. So in other words, the numbers have to be in order for you to find the median. Okay? But also, there can be times when there's more than one number in the middle. If you have an even number of items, then there's no number in the middle. So what has to happen then, you get or the mean of the two in the middle. And again, that's what happens if you get an even number of items. There is no single number in the middle. You'll have two numbers in the middle. And so you just have to find the mean of those two numbers. Okay? So say, for example, I have 1, 3, 5, 9, and 12. Is this set of numbers in order?
No.
Yeah, they are. Okay. I put them in order. Yeah, so they're in order. So all I need to do to find the median is find the one in the middle. And the number in the middle in this case is 5. Okay? So the median, and median doesn't have a special symbol like the other one, median is 5. Okay? Now, that's all well and good, unless I add another number to it. Okay? Let's say I have this set 1, 3, it doesn't really matter, 4, 5, 9, and 12. Now if you look in the middle, there's not one number in the middle, there's two numbers in the middle. All right? So what we have to do is then find the mean of those two numbers. And it's important to remember there's two of them because that's the number you're going to divide by, right? So we take 4 plus 5 and divide by 2. Because there are two numbers and you just add them together. 4 and 5 make 9. So that's 9 over 2, which gives you 4.5 when you divide it out. And you remember, you'll have a calculator. If you can't divide 9 by 2, that's fine. So then for this one, 4.5 is the median. Now, that's not just those two numbers with a decimal in the middle of them. We actually did the math, okay? So say, for example, you had 10 and 15. 10 and 15, it would make 25 divided by 2. So it's going to give you a very different number. So don't see patterns where they don't exist. Yes? Yep, it's halfway between those two. Mm-hmm. That's what dividing by 2 does. Okay? All right. Now, there's one more that we need to talk about, and we've already talked about it in this class, and that is the mode. And that is simply the number that occurs what? There you go. Think mode and think most, right? Comma, if any. And there can be two modes. So you can have a case where you have no mode, or you can have a case where you have more than one mode, or you can have a case where there's one mode. If you have more than 3 modes, then don't worry about it. There's no real mode because it stops doing you any good. Okay? So, just looking at a set of numbers, say we have 1, 2, 3, 5, 7. 3 is the only number that occurs more than once. Therefore, the mode is what? 3. Okay? Now, what if I added 2 more 7s? 7 is the number that occurs most often, so the mode is 7. Okay? No longer 3, right? Because 7 occurs more than that. Now, what if I have 1, 2, 3, 5, 7, 7? 3 and 7 both occur twice, right? So I have 2 modes. What are they? 3 and 7. Okay? And if you had more than that, more numbers that occur, then don't worry about it. Now, you'll sometimes see a case like this. 1, 2, 3, 4, 5. Does any number occur more frequently than any other? No. In this case, there are two options, and we'll look at how the book does it, but there are two options. It's either all the numbers of the mode, because they all occur just as often as any other, or no mode. And again, you're going to see it both ways, depending on the stats book that you're using. Some statisticians say they're all the mode because they all occur exactly the same number of times. And some of them would say there is no mode because no number occurs more frequently than any other. So you need to be flexible here. But if our book says no mode, then don't say all. If our book says all, then don't say no. Okay? So pay attention to the way it's presented in the particular class you're using. Otherwise, you could make a mistake and someone will say, no, we said in this particular course we're going to use the phrase no mode. Right? Generally, this one is more popular. Most people would say there's no mode. Okay? Especially as you began. But do you see why you could also say it to all of them? Because they all occur the same number of times. So they all occur the most times. Right? Okay? Okay, so what we're going to do is we're going to go to the book and we're going to look at a few of these together, and then I'm going to set you loose so you can practice. All right. So, here we go. It's on page 368. You should know that. Page 368. You don't have to look on yours, we can look on mine. So, when we analyze numerical data, we need to understand how numbers are distributed. And one of the most important measures is the measure of center. We're also going to talk later about how the data is spread out, but we're going to talk about that next time. And we'll continue to talk about that. That's very important data as well. And here you see the three that we just talked about. The mean, also known as the average. They're all averages, but the median and the mode. The mean or average is simply the sum of the data values divided by the number of data values. So we did that. So here we'll look at an example. Here, find the mean of this data set. Now, one thing you'll notice is they don't bother to put the numbers in order. Right? But if you're asked to find the median, you must put them in order. So, and besides that, numbers in order are usually easier to work with. So I would tell you that I would not count it wrong if you did not, but I would suggest that you put them in order. I'm also going to remind you something. We haven't used this in class, but have any of you used this self-tutor? If you're on one of these, there's an example where it says self-tutor and you click on it, it'll bring up a video that'll work through the problem. So if you ever want to do that, they're there for you. Okay? So all they did was add up all these numbers. That's what they're doing in the top. And why did they divide by 8? Because there are 8 numbers. Good. So they added it up. It was 96 over 8, and they divided that out and got 12. Okay? So the mean of this data set is 12. Okay? The median just means the number in the middle, but that's only if it's an odd number of numbers. If there's an even number of data values, then you have to find the 2 in the middle. So look at this one. So for this first set, 1, 2, 3, 4, 5, 6, 7. So that means there's going to be a number in the middle. Now, the first thing you have to do, though, is do what with these numbers? Put them in order. So they put them in order, and the number in the middle, when they put them in order, is 9. Look at this. If you didn't put them in order, the number in the middle is 14, and you'd be wrong. Okay? They have to be in order. Now, the second one, they put them in order, and there's not one number in the middle, but 2. So they just added the 2 together, divided by 2, and you get 6 as your median. Okay? So in other words, it's the mean of the 2 numbers in the middle. And then finally, mode is the one that occurs most often. If you have exactly 2 modes, it's often called bimodal, like bicycle, right? Bi means 2. So that means 2 modes. Bimodal means 2 modes. And so you'd list both values. Okay? If they occur more frequently than that, then don't use the mode. So they would just say no mode. So this book is a no mode situation, not all. Okay? All right. So here's one where they're asking you for everything. It says an exceptional footballer scores the following goals in her school during a season. Here are the data points. Notice there are zeros here. Does that mean I just get to ignore them? No, you be careful. Okay? So first find the mean. So they just took the sum of all the scores. So they just added them all up. And they said that was 45. And then they counted them, and look how nice they were. They grouped them in groups of 5. They often do that to keep you organized. There are 4 groups of 5, so therefore 20 data sets. And 45 divided by 20 is 2.25 goals. Okay, so on average, she scores 2.25 goals per game. The ordered data set, they put it in order. And the two numbers in the middle are 2. 2 plus 2 is 4 divided by 2, so 2 goals. So you see those two numbers are very close together. That does not always happen. That's why we take different measurements, because sometimes some numbers might be more accurate than others. And then finally, the one that occurs most frequently is 2. So in this case, most of the numbers came out to be 2 or very close to 2. That does not have to be the case. Many times, the mean is affected by outliers. So let's say one game she had scored 40 goals. Not likely, but it could happen. And if that's the case, then the mean would be way more than 2. But the number in the middle might still be 2. And the number that occurred most often might still be 2. And those are more accurate representations, because even though she scored 40 in one game, most games she scored about 2. Do you see what I'm saying? So the mean can be affected by outliers, where these others are not. Okay? All right. So here we go. First, we're just going to find the mean of a couple of sets. So you're going to practice along with me, and then I'm going to call on somebody. So everybody plays.